All right, for those of you that don't know, I started an aeroponic high pressure system with a team of mine in university as our final mechanical engineering project. I did a couple videos in the past on LinkedIn uploading the system and the status of that. That was almost 2 years ago. So I've now since then moved to Thailand and I took the concept with me. So it's been through a couple renditions and I finally landed on one that I want to share with you guys. Today I just want to give you an introduction video to Aeoponics, kind of give you a reminder of how it works, how the system operates, how the controls and what kind of variables are involved, and see what you think. So if you've got any questions at the end of it, please put them down at the bottom and give me a little encouragement along the way, because I really like to know what you guys want to see, what you guys want to know, and any feedback you might have. This is a learning experience for me as well as for anyone that wants to join the journey with me. So please share and give me a like if you got the time for it. So I planted these little tomato plants about exactly 7 days ago. They had been planted in dirt for about 3 days prior to that. And during the transplant process, a couple of them started struggling moving from the dirt to these buckets. So the way that this system, and you can see that, item number 1, item number 4 there, they're quite small. Item number 3, I had to trim up a bit because it was nearly dead, but they came back to life. These ones have done consistently well. I think I might have blasted these guys, number 1 and number 4, a little too heavy with the LED, and that might have been why they had an issue. Number 3 could have been the same thing, I don't know. But here is the overall system. I'll try not to get that weird LED shake here. The camera doesn't like those lights. So you see I've got a high pressure pump there that draws water from this reservoir that I've got covered up. So I made this system using all local components, and that's why it looks the way it does. Though I think it turned out halfway decent. So you can see this thing holds about 170 liters of water, which is plenty for the 6 buckets that are designed to go on here. At the moment I just have 5. But that will be updated here very shortly. So the way that this works is I've got this small particulate filter connected to this high pressure pump, which then pushes a significant PSI through this high pressure manifold hosing here and tees off into each one of these buckets, or the root growing chamber. And if we open this lid up, you can see the high pressure mist. Those droplets, they're just micron sized, very, very small droplets, almost like a fog. So I've got it blasting on intervals, and I'll show you how that works here in a moment, but I want to go through these plants and show you the interesting thing about the roots when you get these little micron sized droplets. The real benefit of this system, actually when it's completely dialed in, as reported by NASA and their research in the 90s, is you can get a triple time growth rate by using a system like this. And the reason being is what I'm about to show you. So, like I said, 1 week ago, see the heavy green? That was the root. Right? It had none of these white strains coming out. And as you can see, at the moment that I put it into these high pressure root chamber environments with the micron size mist, it just started sprawling. And you get all these little hairs coming off of the mother root and then off of her children, right? What that does is it significantly increases the surface area of the roots, which therefore increases the uptake of nutrients. And it also gives, you can see there's no media. The one major difference between this and hydroponic, other than the high pressure mist, is you don't have any type of media that holds this plant. I've cut these foam inserts as the only support. These are tomato plants, I'm not sure if I mentioned that. You want to give as much surface area as possible to allow for root growth. And as I just mentioned, that surface area correlates to nutrient uptake. The more nodes you have on those roots, the more nutrients that it can absorb per rate of time, which it then can put into the growth of the greenery and the fruiting. And that's it in a nutshell. That's it simplified. Over here I've got my messy controller that I rigged up. Actually, this is a homemade controller. So there's a couple important variables when monitoring a system like this. And here they are, right? Try not to get that flicker. So I've got 3 different temperatures that I'm reading, as well as the relative humidity of the room. The pH and the EC values are currently on null, arbitrary values, because I do not have them plugged in at all times. What I do is I plug them in intermittently and check levels. That is because I don't want to degrade my probes any faster than I really need to, and there's not a significant reason why I need to know that pH and that EC value at all times. I typically do it about once a day. Then the on-off, this is something I've programmed to control the pump frequency, the high pressure pump. As you can see, I've got it on for 8 minutes, are the units on there, and off for 1 minute. Those are controlled through this potentiometer. So if I turn it to the right, you get intervals of half minutes. So you can turn it all the way on to 45 minutes and all the way down to 0. So if I wanted, so right now the pump runs for 8 minutes and it's off for 1 minute. If I didn't want the pump on, all I simply have to do is turn this back down to 0. And this is all programmed using a nice little Arduino microcontroller. But I think that's it for today. The video is getting a little bit long. If you like the video and you're curious to learn more about how this system works, or you have any contributions to how I can make it better, I'd be happy to hear them. Love to hear your thoughts. Leave them down below. Talk to you soon. Cheers. Bye.